It. One more important topic we are going to discuss, and that is Gibbs Duhem equation. So that is also part of your syllabus. So if we talk about Gibbs Duhem equation, so what does it mean? Let's try to understand what it means. So we have discussed that chemical potential, this is dependent on the composition of the system, because in equation number 70 we have this change, this G is mu1 n1 mu2 and n3, like that. And if a small change in this Gibbs free energy dg is concerned, then this small change is mu1 dn1 n1 d mu2, correct? Because equation number 70 is clear. G is equal to N1 mu1, N2 mu2, Nj mu j. So all these terms consist of product of two terms. One is number of moles, another is one is chemical potential. Both are variable. So when we would like to differentiate this equation throughout, equation number 70, on differentiation, what will we will be having? We will be having this equation number 71. So a small change in dg will be equal to mu1 n1 plus n1. So chemical potential is taken as constant. Change the number of moles of first component. First number of moles of first component constant. Change the potential, chemical potential of the first component. So like that, we are having that many terms in this expression. Simply, we have differentiated as product of two functions. So now if we separate differentials of chemical potential and differentials of number of moles, we are having two type of terms. So half of these terms are differential of chemical potential and half of these terms are differential of number of moles. So if we differentiate them, then this dg will be equal to mu1 dn1 plus mu2 dn2 plus mu3 dn3 plus mu4 dn4 up to mu j dnj. So these terms will be due to differential of the chemical potential. Plus is equation number 72, this is wrong equation. We will be having plus sign between these two brackets. So plus another term will be equal to n1 d mu1 plus n2 d mu2 plus n3 d mu3, like this, nj d mu j. So in one bracket we are having differential of chemical potential, in another bracket we are having differential of number of moles, correct? But equation number 69 says what? Let's see what equation number 69 says. Equation number 69 says that this mu1 dn1 plus mu2 dn2 plus mu3 dn3, all these things are equal to dj, is at constant temperature and pressure. So if we apply this equation number 69, what will happen? We will be having this dj at constant temperature and pressure. This will be equal to mu1 dn1 plus mu2 dn2 plus mu g. And what we are doing, all these terms n1 n2 n3 nj, these are constant. So if dg is defined like that, what does it mean? If its value is equal to dg, then it means that the other components that are present in this second bracket, definitely these have to vanish. So their value should be 0. So if their value is 0, then we will be having n1 d mu1 plus n2 d mu2 plus nj d mu j equal to 0. So we can conclude that if temperature is constant, pressure is constant for the system, then the system has a dynamic composition, and summation of n j d mu j, this is equal to 0. And this equation is known as Gibbs Duhem equation. And the significance of this equation is that the chemical potential of one component of a mixture cannot change independently of the chemical potential of the other component. So this is physical significance of the system. And if we are having a system of two components, then simplified version of this equation will be equal to n1 d mu1 plus n2 d mu2 equal to 0, because we are not going to the jth component. So from here we can define this d mu1 will be equal to minus of n2 by n1 d mu2. Thus, by looking at the above equation, we can say that the variation in the chemical potential of one component of the system can bring the variation in chemical potential of the second component of the other system. Means if we are varying the chemical potential of one system, we can do a variation in the chemical potential of the other system. So All these things we have discussed, that is physical significance of this Gibbs Duhem equation, its derivation and all these things. So please you go through that.